Okay, here we're going to take a look at how to divide up different areas under the curve. So for example, we could go ahead and take a look at the area under the curve, and if we assume that the total area under the curve is 100%, which is what it is, then we can go ahead and divide this into different sections. And I'll just go ahead and give an example here, and let's see if you can work with me to divide this area up. So let's go ahead and draw a line and just approximate here. The bottom 85% of the distribution from the top 15%. So we want the bottom 85 from the top 15. So just approximating here, if I see the bottom 85, I'm going to draw a line somewhere around here. Okay, and here's my x-axis. And then I'm going to write in here 85%, and that leaves me 15% up here. Okay, so this is the bottom 85% from the top 15. Or we could say that 85% of the values or scores fall to the left of this point here, whatever z-score it is. I don't know yet for this problem. But 85% of the scores fall below this z-value. 15% of the scores fall above this z-value. Okay, now in your text, this area here, if you look in your z-table, would be referred to as the proportion in the body. Or you could think of it as the larger portion of the curve. Okay, that's this area here. So all the way from this point to the end of your curve is the proportion in the body, or the larger proportion. You know, notice how this area, the 85%, is much larger than the 15%. So we call this the proportion in the body, or the larger portion. Now this other area, the smaller area, is referred to as the proportion in the tail. Okay, so from here to about here, we have proportion in the tail. Okay, that's this area here. You can also refer to it as the smaller portion. Now, when we talk about proportions, we're really moving from percentages to decimal form. So if we talk about a proportion, I would convert this percentage of 85% to a decimal. I just move, I get rid of the percent sign, and I move the decimal 2 places to the left. So in a proportion, this is 0.8500, and I'll leave it to 4 decimal places because that's what your text does. And 15% would be 0.1500. So these are my proportions. So you should be able to go back and forth from percentage to proportion. Notice how 85 plus 15% is equal to 100%. And 0.85 plus 0.15 is equal to 1.0. So when we talk about percentages, it's 100%. Or when we talk about proportions, it's just 1.00, the area under the curve. Now what you'll see, you're going to have problems where you will have to divide up your distribution into different pieces, such as 85% and 15%. So to do that, you're going to need to be aware of the proportion in the body, that's the larger proportion, and the proportion in the tail is the smaller proportion. Now there's one other thing you can do here. For proportion in the tail, it's really always equal to, it's less than or equal to 0.5000. Okay, it's less than or equal to 50% of the distribution, or half of the distribution. Often it's much less than half, but technically it could be equal to half, okay, to 1/2. Now the proportion of the body is always greater than or equal to 50% or 0.5000. Now technically, it could be equal to 0.5000, but usually it's greater than that. Okay, so if I had a few examples here, my proportion of the body was 0.6500, then you should be able to determine what the proportion of the tail is. And you could subtract this from 1, or 1 minus 0.65, and that would give you 0.3500. Okay, another example. If I had a proportion of the body of 0.55, then the proportion in the tail would be 0.45. Notice how these two add up to 1, just as these two did, and just as these two do. Okay, they all add up to 1. If I had a proportion in the body of 0.59, then the proportion in the tail would be 0.41, and so on. So you should be prepared to be able to divide up a distribution, a normal distribution, into various areas under the curve, where you have a proportion of the body, or what I like to think of as the larger portion, and a proportion of the tail, or what I like to think of as the smaller portion.